Heyo. I really need like bumpers and music and like transition screens and crap to be a real streamer. I mean, maybe before then I should probably consider just like a regular time. See, the problem is I really like having a nap around the time that I would normally do it, which is why I'm doing it now. But we are gonna do some work today. We are. There's this little thing, this little side quest that I need to do. And I'm just going to re-scoot myself here. Oh no, don't do that. Ah, shit. That was dumb. Oh, whatever. Okay. Never mind. Anyway, so maybe I'll go to this screen. Actually, no. I'm going to go to this screen. And just try to describe what it is that I am doing. So any of these, like, so first of all, this is the IBIS tool. This is the thing that I've been working on for freaking eons. And it's like also like part of those eons I have been trying to begin to prepare to proceed to port this tool over to Intertwingler, which is the substrate backend application server, whatever you want to call it. And this actually is describing like this issue network is actually describing like open issues, or not even open issues, closed issues too, of Intertwingler itself. And this is the IBIS tool. It doesn't have a name, but it will once I port it. And so the job is to port the IBIS tool to Intertwingler. This is a green thing that should be in the middle there. Yeah, this guy, yes. And these are all the things that we have to consider when we are porting IBIS tool to Intertwingler. Now, the problem with the IBIS tool is, like, for example, like when you start typing in one of these things that will get linked up, or maybe not linked up, maybe it'll get generated. But there's like type ahead, like there's like a data list on the web page underneath this that has all the autocomplete, right? And so like the way that I did this on this thing, and I don't know if I can, well, let's just try here. If I like duplicate, and then I go to like resources, I think it's called resources. Yes. It's probably gonna get angry, so I got to turn off the friggin' template. Oh yeah. So let's just turn that off for a second, and you'll see what it looks like under the hood. I think. Maybe not. Oh yeah, right. All classes. And you can see when you click on these things, oops, this is probably better if you do that. Yeah, all right, let's just bring that online again. I think this actually works. Maybe not. Okay, doesn't matter. Bottom line is, there are these resources, they get pulled in to be the things. They're just regular web pages that have got like metadata embedded in them. I have a less jammy wine tonight, which is good because that jammy one was gross. But anyway, so there are these things, I'm calling them catalog resources. And the way you make stuff in Intertwingler versus this prototype, the backend prototype for this is not, I mean, it's like 11 years old, and it's like a super hack, and it's like the problem is I can't develop this, and I haven't been able like to really like do anything significant with this tool in 11 years. And the reason why is because the back end needs to get completely overhauled. And I spent 2023 or most of it, and most of last year as well, writing this thing called intertwingler, which is supposed to replace that. So all it is just a bunch of web pages that have a bunch of stuff, and it's a bunch of metadata, and then you can transform it into JSON or Turtle or whatever the hell you need to transform it into in order to do your stuff. But at the moment, that's sort of the idea. So where we're at with, for instance, let me just try to bring up the catalog resource here. I'll make this bigger too. Classes. Is that all classes? Yeah, okay. Whew. So I will duplicate this. Localhost. And I'll just put that UUID in there and see what this brings up. I don't actually know yet. Yeah, okay. I don't actually know why this is cooperating. Normally it's just been bitching at me, but whatever. Anyway, you can see that these are a whole bunch of things, and there's like documents in here, and they're like asserted, inferred. That's interesting. Oh, yeah, no. Okay. That's a note. Doesn't matter. The idea is you've got all these classes, and then you have all these instances, and then you can you're supposed to be able to click on this, and then it goes to something like this. And I don't know what this actually is showing. I think it's just showing everything, which is why everything's in here. So yeah, I was working on what's it called? I was working on so like I can do like instance of, and then like I can say like SCOS concept, and then it'll run that, and it's just your standard issue like paginated, whatever. Yeah, that's weird. What is that? Oh, because it doesn't have a class. It doesn't have a type of. No, that's a thing that needs fixing. What is weird? I'm just going to change this actually. Actually, no, we're not going to do this quite yet. We're not screwing around with that yet. Because that's like too low level. That's not what we're doing right now. What are we doing right now? What are we doing right now? We are, we're designing like an identifier. And so, actually, yeah, when you go, let's try that. this. Yes. No, we wanted that. So yeah. This is a, we can actually grab this, we can go over here in the shell, and we can like already have serialized host language XH201. There's like people running around outside. Input format RDFA, output format turtle. We can just see what that generates. Host language. Okay. Come on, you can do it. Okay. Input format RDFA. Oh, no, that is right. Oh, does this have to go first? Dumb. It like complains. Anyway, yep, it did have to go first. Freaking God. Okay, so that is it's got all the data in there. That's correct. The only thing is it doesn't have the namespaces yet, but that's fine. I'm not worried about that. Actually, it would be kind of nice to, well, yeah, it would be kind of nice to have a transform that turns the, or that goes and repairs the namespaces so that you don't have to freaking worry about them. Although that would just encourage sloppy coding, so maybe not. But these are the kinds of things that you discuss. Anyway. But you can see that this is a cube. This guy. This is the same stuff as this data cube ontology. And oh God, okay. Yeah, so this is the same as this data cube ontology, and yeah, so so if you see in there's this like O.99, for example, fragment, and I'm just generating them by sequence, and of course that is bad, right? Like that's not good. And the reason why is because if like anything ever gets inserted or changed or whatever, if something gets added or removed, then that number is basically going to get reassigned. Well, if anything happens, anything gets added or removed before that, then that number's not going to point to the same thing if you try to point to that as a URL. And that's the basic problem that we're trying to solve is how do you make these fragment identifiers, but how do you make them permanent? Like how do you make them durable is the plan. What's this? So without further ado, that's what we're gonna do. Now the name of the game. Swear to God, every freaking halftime it doesn't do that. So the name of the game, of course, is the worst acronym in all of computing. Is this on the screen? HATEOAS, hypertext as the engine of application state. I don't know how you pronounce this. HATEOAS, whatever. But if you ever actually read the rest paper, the actual dissertation by Fielding, he talks a lot about hypertext as the engine of application state. Or hypermedia as the engine of app. It doesn't matter. In this case, it's definitely hypertext. And so going back to the actual initial problem of like how do you populate, like how do you supply these things with, you know, type of heads or whatever, because it's not just going to be this is the other thing, is there's going to be all sorts of graph tools that are going to need to have some kind of like type ahead, you know, autocomplete thing. And so the question is like, how do we supply, like, how do we create the resources? Like, what do the resources look like? Like, this is like purely a design problem. It's just like, what is it? You know, there's a million ways to do this. Like, which one are we going to pick? And the way we're going to do it is we're just basically making a microservice, because that's the way how intertwingler works. Like when this gets ported over to intertwingler, because that's the goal. The goal is to port this over to intertwingler. The task, the need, is to replace this dodgy prototypes way of supplying type aheads, autocompletes to the interface. Replace that with something that intertwingler can use, which is a microservice. Like, and that is this thing, this like catalog, and that is like a network of stuff. So when you have, oh yeah, right, I didn't have, so this is like, you gotta tell me when I am not on the right screen. So let's just do this over. This is the catalog, friggin', this thing is a microservice. I would love to be able to click on that, thank you. This is the IBIS tool. We want, the front end has been cleft off, it's been separated from the back end. The back end is still this dodgy prototype. I want to move the front end onto the new intertwingler back end. The thing that is currently missing is these autocompletes, or like the thing that generates the auto, or that supplies the, on the back end, that supplies the autocompletes to the front end. Thank you very much. That is this microservice on the right. The problem is the actual problem like now is like the zoomed in problem is these fragment identifiers that are in the that are in these. So if you go to these, and of course I'm using them, but you can see this like ID 0.2, ID 0.1, whatever. So those are bad, obviously, because they're sequence numbers, and if anything in the sequence gets messed up, then, or it changes over time, then obviously those URLs are going to be bad. So what we want is we want durable identifiers that we're going to shove into those, into the table rows, basically, because the table rows, each table row is going to have an ID. And the reason for that is, going back to this guy, Hados, whatever the hell, however you pronounce it, Fielding later called it the hypermedia constraint. The whole point of the hypermedia constraint is, so that, sorry, I'm just getting a message here. The whole point of the hypermedia constraint is that the application actually doesn't have to care about what the URLs are, because they're being told. So they're just being like, go here. And then you go there, you know, the application goes there and they get some data, and then it's like, go here, go here, go here, go here. And all you're doing is just following breadcrumbs, basically. And so if we were going to look at this again, I'd love to be able to change that. If we were going to look at this again, so like this page, the page that this is, you know, we would just call that, and then if we go here, it is not cooperating with me. So like, let's just say like this is the initial page. Is my head in the way? No, it's not. All right. So this is the initial page, the page that I just showed you. In fact, I can like do that maybe. No. Okay. So, are we there yet? Yeah, we are. Okay. So that's the initial page. The little screen on the right is the page that I'm trying to draw a little diagram of on the left. Then there's going to be some kind of like index. And then the index is going to have, I mean, there's actually like another thing in between here, but it doesn't matter. The index is going to have by classes. These are, and by property. And those are the summaries. And so if we were to go, let me just go back to this. This is one of the summaries. So this would be the by class summary, what you're seeing on in the little screen. And like what this is showing you is like the class and then the number of things that are either asserted or inferred. And that's actually like asserted plus inferred. And then the idea is you click on this, for example, the by class, and then you'll have like the enumerated, like you'll just have like the inventory. And the property has two, so it's got the domain or subjects. This will just be instances of a class. This will be subjects. And then another one is objects. And so the idea is the application can follow just using semantic links. It can say like, okay, so the page here, like just the front end can just traverse links because this is a type, and then you'll get to here, or you'll get to here, or here, whatever. And so this whole thing, not that part, because that's not part of it, but this whole thing is a microservice. Now, and this is all parameterized too, so like, these inventories are parameterized. That was last week's thing, is to figure out the parameterization stuff, which was damn tough. Everything about it's funny because what I've been doing with this work is like, if you were just gonna go and do it in the normal way that everybody does web apps, like I'm sure it would be easy, but like since like I'm doing it like 10 different weird ways at once, then it's actually kind of hard. And it's mostly decision problems. It's mostly like, oh geez, like there's gonna be consequences if I don't sit down and figure this out right now. Like we can't. Anyway. So the page finds the index, and then they can oh, those are, yeah, anyway. So these are the summaries. Learn to write. Summary. God. This is another summary. And where else are we here? And yeah, so in the case, and if we go to, yeah. In the case that, so again, like the problem we're trying to solve is this, like this type ahead, this, trying to procure the data from the back end to the front end and whatnot. But again, like the front end does not need to know anything other than like what the type of this link is, and the type of this link, and the type of this link. And then all it's got to do at that juncture is just read out you know, this is the instances. So the goal is to be able to make like a kind of arbitrary one of these. Like this is a very specialized thing that only handles like a certain set of vocabularies. But it's like if you want to connect arbitrary stuff arbitrarily, like it needs to be more robust and it can't be like hard coded, which it currently is, and that's the reason why this prototype backend. What you're looking at is obviously the front end, but the back end of this thing is just like sclerotic as all hell because like all of the inferencing shit is hard coded, and so it's like if you want to add another inference, you got to go and hard code it, and then if you want to add another one, you got to hard code it. If you want to add another one, you got to hard code it. And the whole idea of porting this over to intertwingler is like it just takes care of all that, and you don't have to hard code anything. So back to the identifiers. And so what we want to do is we want to figure out, and this is a design problem. We want to figure out like how to create these durable, like deterministically generated identifiers or fragment identifiers, so that we can have these things so that, and I'm just going to go back to this again, so that if you're out, because this is the summaries, that's the summaries are the things that are going to be the data cube stuff. The data cube stuff is going to have like however many rows, we don't know. The instance inventory is just going to point straight to the object, the resource itself, so that's fine. Those are dealt with, but like there's going to be so the links going from here to here is going to be like one per table row. And so that table row, every table row needs an ID. It needs a fragment identifier. And I just had a sequence number in there, but again, sequence numbers are problematic because if anything changes, the link goes bust. And what I want is I want to be able to have a backlink from here to here so that these go back and forth to each other. And now, so it's going to need to go back to a fragment identifier. And in that case, like this microservice, which is going to be, or this whole thing is a microservice, but this resource that's embedded within the microservice doesn't know anything about anything else. It's just generating links. So it's like, how can I deterministically generate these links? Is the question. And so that is the challenge tonight, is to figure out these identifiers so that I can generate these backlinks, so that I have my nice, pretty HATOAS thing that works correctly. And because like one of the stipulations for all of this work that I've done so far is like everything has backlinks, but it needs to be able to know what the backlinks are in order to implement, execute, whatever you want to call it. So, yeah. Okay, so I'm gonna go back to the main screen. This guy. So I just like writing to myself, and I can read off what this says because it's probably small. So first of all, there's a new UUID RFC out that is 9562, and I also have a fragment identifier, and I can just like insert UUID. They look like this, and the reason why these identifiers look like this, I can make them big, is this is a UUID, and I can like transform it into a UUID. And because it is a UUID. And so and so it's isomorphic. This symbol is isomorphic to a UUID. It's a stable identifier. This is something that's called a UUID NC name. There's an IETF draft out for it, but it's a draft still because I do not have the resources at the moment to push it through to an RFC, but I think it should. So if anybody wants to vote for it or however the hell you vouch for it, it's more like what you do with the IETF. But anyway, so what I mean with that is I can yeah. Anyway, yeah. So like, I can use those as fragment identifiers. That's the sort of starting off point. Now, what do we put in them? Well, we put a UUID. Now, it turns out that RFC 9562 specifies a UUID version 8 with a truncated, UUID version 8 is fully user defined. And so the way that I would define it is I would just put a truncated hash, SHA-256 hash in it. Now the question is, SHA-256 hash of what? Because it's got to be some kind of well-defined string of bytes. And the question is, what should they be? And so my inclination is to come up with like a formula for like what goes into the input. Because once we figure out what goes into the input, the rest is easy. The rest is straightforward. This is why I have this in code comments right here, because I'm actually going to write the code that does this. So, actually, let's just look at the docs for those UUID tools thing. Because this is going to be another issue. Parse int, parse raw string. Okay. We have a parse raw. Let's figure out what that looks like. First of all, require module secure random. All right. Well, whatever. Rand what? Random bytes. Oh, yeah, okay. So bytes. That's weird. Yeah. 16? Sure. So then I can say UUID parse. What did I say? Parse binary? Parse raw. Yes. Yes. Okay. Even better. But so then what we do is we would just mask those things because that's actually like, this is like an invalid UUID. You can see, well, yeah, there's no UUID version C, which would be version DEF 15, 14, 13, 12. 12, version 12. And then I'll just like require UUID and CNAME, which is my module. I made it. And so what I can actually do, so what I'm imagining, first of all, 96 bits is what? 96, 32, 96 divided by 8. Jesus Christ, 12 bytes. So that's the like length of the hash I'm thinking. Because the other thing too is also I want to be able to determine like that this is one of these hashes. And so I'm actually thinking of, if I just said, okay, hang on a second. You know what it is? It's in UUID, like Ruby doc, info gems, UUID. I have like a little, yeah, make cheapo base64 UUID and CNAME. So if I just did this, oh, right. Hooray. Yeah. Okay. So the difference would be X O equals I, and then X 1 dot 3. Oh. Oops, 1.4. So if I said stable fragment identifier equals SFI underscore. Does that work? Yes. So then I say UUID and CNAME convert from and CNAME and then X Y. Yeah. So that is a valid UUID, this like 485 blah 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 blah. Can I make this bigger or is that gonna wreck shit? Oh no, I can. Is it gonna wreck it? Maybe not. Yes. So this is like what I was sort of interested in. There's like 485 to 3F is the first 24 bits. And if you can see this ISFI, so intertwingler stable fragment identifier, or it should just be ISFO. Yeah, let's see this. Same in front of version 0. Okay. 48 5D 3F. It's actually very strange. X. Oh, D3 is, it's not 2, 3 anymore, it's D3. That's why it's just off by one element. Yeah, so that's what I want. I want to have, so that'll be, and so you can see the version identifier, or the version component. Like if you didn't know this, UUIDs are, like, there's actually structure to them. They're not just like random bytes. So like this guy here and this guy here are masked. And everything else can be whatever you want. Well, depending on the actual thing. So let's just look at X again. So this ISFO, so that's stable fragment 0. As in version 0. And then we'll just increment that. And the I is actually just a convenience, or it's a I for intertwingler, but coincidentally, the shit. Is this? Oh no, I am working, but what the hell happened to the camera? That's incredibly weird. It's like the camera crashed and I didn't notice. Anyway, where was I? We're done. Was I? Okay. So, it could be an underscore. It could be like, this is the other thing too. Is this like it could be a hyphen or it could be an underscore. Like I don't actually know if I want. Anyway. And then we just take after that. This is just 96 bits of hash, and then the last one is the other masked one. And then we look at that. Yeah. Yeah, I like this. I'm just trying to decide between the underscore. I think I'm gonna go with underscore. I don't know. This is the thing. What actually happens then if you say UUID NC name to NC name 32? Why? JBot. All right, JBot 6NG. Whatever. That'll always be that, I'm sure. Because it's the 485D3F is the same as SF0 underscore in base 64. 58. What does that look like? Probably a goddamn mess. We're good. I like this. I like this. This is a solution. So everything after the underscore is 96 bits of hash of SHA-256, let's say. And then the question is just what do we put in the SHA-256? So I'm just going to like copy this. Ooh. Come on. Yeah. Beautiful. That is perfect. That's exactly so. So then you just sort of have x. Then you would just have like a URL that's like this. Come here. Where you got like foo.biz, and this is like slash, page, duh. And that'll be a stable identifier. Now it's the question is like how do you organize the content? So everything from like here, here up to the penultimate one. The last one is the bookend. It is there would be the J would correspond to the 9 there, and the I at the front of the identifier would correspond to the 8 there. So like A, B, C, D, E, F, G, H, I, which -1 because there's 0. Anyway. Yeah. So this is the sort of, this fragment identifier is what we're after here. And yeah, so where I'm at right now is like, okay, like what, like, so we've decided we're going to use SHA-256. We've decided we're going to truncate it to 96 bits because, I mean, considering what goes in there anyway, there's like no way there's going to collide. Are you kidding me? Like, you take a hash function like SHA-256 and you say, well, the input can only be this domain of stuff. Like, the possibility that you're going to get a collision with that, forget it. It's not going to happen. So, anyway. Yeah. But, like, 96 bits is what? 2 to the 96. 2... O is X. Not X. I don't remember how you do it in Emacs list, but whatever. What do you do? 296. Log 10. Log? Oh yeah, sorry, you can't do that. 2 to the 1 to 10 to the 20, almost 10 to the 29. And of course, if you wanted to be a douche, you could cut it in half because of the birthday problem, whatever. 48, 14. So that is what? 2 to the 12, so trillion, 100 trillion, right? Yeah. Is it half the bits or is this -1? -1 bit. I can't. No, it's half the bits. 28, or is it 281 trillion, 474 billion, 976 million, 710,656. There's your collision space for 96 bits of hash. Like, not going to happen. Anyway. But yeah, we still have to figure out like what goes into this goddamn thing. And this is, I guess, where the code comes in. And so if I said, I mean, I think we'll just be generating these things too as like compact IDs, and then they can expand out to proper UUIDs. I think that's what we're going to do. Because I, for the first one, anyway, whatever. All right, let's like make UUID durable fragment terms and we'll just actually just because I don't actually know if this is necessary, but whatever. Make durable fragment terms, and then we say terms.map. Oh, do I need the? I need freaking. Obviously, I need the SHA-256. What the freaking hell am I doing? Okay, I don't even remember where this goes. Ruby SHA-256. This is in Ruby, by the way. Digest SHA-2. Okay. Is it digest SHA-256? Just a second. Require. Oh, okay. SHA-2. Module digest. I mean 3.2, whatever. Just require digest. Okay. Okay. Easy enough. Require digest. All right. String equals, do that. What is your problem? That was it complaining about? Jesus Christ. Let's call it input. There's another issue that's going to be UTF-8 normalization. I don't know if you know this, but there are 4 different ways to normalize UTF-8. NFC, NFD, NFKC, NFKD. So yeah, look those up. They will produce different byte sequences. Just saying. Digest. Okay, so hash equals digest SHA-256. We want raw digest, just digest, okay. And then we want, oh, we'll just do this. 12. That should work, right? If I just say like, the take 12. Oh, there's no take. Whack. Of course. Whatever. No, 1.11. Oh, no. What? Okay. Slice. Oh, 12. Jesus. Okay. That. Yeah, that's the hash. The raw bytes of that. Do I have the base 64-age here? I do not. What happens? Hey. You know what? Hey. if $0 equals file. It's kind of funny how this has this, like Ruby has this idiom like Python. Require pry. Bindings. No, it's binding, obviously, because it's coming up in purple. Okay, and then I'm going to sneeze any second now. Maybe not. We'll find out. It'll be amazing. Digest shot 256, because of what we're seeing. So, okay, first of all, the terms, this like 2sx, so like this will generate a string of terms. I'll just call it flat. Separated by spaces. This is sort of like, this is my vibe. I'm not going to try to justify this. Generate a truncated SHA-256, a 256 hash truncated to 96 bits. We're gonna like base 60 code that baby. And then what? Yes. So it'd be 64 equals base 64 save code 64 hash. We don't need the padding on that. And then we want no, we want ISI 64. Okay. Let's try it. You go away, goodbye. Well, I mean, I could have kept you, but whatever. Ruby dash I live, I don't know, whatever, experimental. Yeah, say it. What? Where's the ooh? Oh, that's no good. That's not supposed to be there. Try it again. Yes. X equals. Then we say, oh no. We want, what did I say? Stable fragment 0 underscore. Yes. Yes. Y equals UID cname dot from X. Yes. Okay. Now I was using like RDF type. I mean, I could use anything. Like, so if I said RDF, RDFS dot class, whatever, right? And there it is. I think that's a good start. What time is it? Oh my god, I've been at it for an hour. Look at that. So in this way, And then if I said like, I don't know, RDF, vocab, SCOS, concept. But then I could also RDF, URI. Yes. That's exactly what I wanted, you dumbass. Jesus Christ. This is the kind of thing that's like basically going to be what's happening anyway. This is sort of the plan. Maybe it's the other way around. Maybe it is. Let's just do this. Boop, boop, boop. RDF, vocab, SCOS, concept. Yeah, okay, let's just like. This would be like S equals this. Yeah. Yeah. Okay. And then you can kind of imagine that just like that works. And then U should just be like UID. No. No. U. Yes. Perfect. Beautiful. Amazing. Gorgeous. Yeah. Yeah, there we go. There we go. R. That's what we want at the end of the day. An RDF URI. Well, that was an hour. That was my job, and now my job here is done. Nobody's watching, so I am going to sayonara. That should not be. It should be that. I don't even know, man. Are you doing it? You're not doing it. Yeah, sayonara.